Today we're going to talk about percents. So what exactly is a percent? Well, a percent is a ratio that compares a number to 100, and it's expressed as with the percentage sign. Also, we mentioned it's a ratio that compares a number to 100, but percents can be modeled on a circle graph. The circle graph below, as you'll see here, shows the results of a survey in which 25 students were asked which type of music they preferred. So if we take the hip-hop example, 16% means 16 per 100. As a decimal, it's written as 0.16. As a fraction, it's written as 16 over 100, or when we reduce that, it's 4 out of 25. So 16% means that 4 out of the 25 students that were asked which type of music they preferred hip-hop. Right, to better understand percents, let's look at the relationships between fractions or ratios, which we've been talking about, decimals, and percents. So here we have a chart that shows some different ratios. For example, 3 over 10 equivalent to 30 over 100, because remember we said that percents are comparing a number to 100. So the ratio 3 out of 10 rewritten in terms of 100 is 30 over 100. As a decimal, it's written as 0.30 and has a percent as 30%. So what's the process to get from ratio or fraction to percentage? First, to convert a fraction or a ratio to a decimal, we divide the numerator by the denominator. Then, to convert a decimal to a percent, we multiply by 100 and insert the percent symbol. And just a reminder, when we multiply by 100, all we're really doing is moving the decimal point 2 spaces to the right. Let's look at an example now. But this time, we will start with a percentage. So we have this chart here which shows us the music type, the percentage. We want to fill in the decimal and the fraction. Starting with a percentage, first we remove the percentage symbol and divide by 100. Remember, going from a decimal to a percent, we multiplied by 100 and added the percentage. We're going to do the reverse of that now. Dividing by 100 simply means we shift our decimal place 2 spaces to the left. So 48% becomes 0.48. Now that we have our percentage in decimal form, we can easily convert to a fraction. 0.48 is written as 48 over 100, which is simplified to 12 over 25. We follow the same process for each of the others. So again, we fill in the first one, 0.48 equals 12 over 25. 24% equals 0.24, and that is equivalent to a fraction, 6 over 25, and then we fill in the rest, and we see our completed answers there. For the next problem, we want to look at comparing and ordering percentages, fractions, decimals, whichever format they're in. So we have the problem, write 0.075%, 3/4, 0.41, and 100% in order from least to greatest. Now, you look at this and we see that, yeah, we have 4 numbers, but we have 2 percentages, 1 decimal, and 1 fraction. So how do we approach a problem like this? The first step is to convert them so they are all in the same format. Now we look at that, we have 2 that are already written as a percentage. So let's convert the other 2 to percentages as well. We have 3/4. First we convert to a decimal by dividing 3 by 4. 3 divided by 4 equals 0.75. Then we multiply by 100 and add a percent sign. So we have 75%. Finally, we look at 0.41. This is already in decimal form, so now we just need to multiply by 100 and add a percentage sign. So we have 41%. So now we have all four of the numbers that we're asked to put in order in terms of a percentage. If we put them back in order, keeping them in their original forms, then we have 0.075%, 0.41, 3/4, and 100%. Next, we want to look at a term called estimation. Estimation basically just means we're estimating, not giving an exact number. When do we use estimation? We use it when we're figuring out tips, when we're calculating sales tax, when we're tithing, when we're looking at discounts on merchandise or things we're purchasing, or maybe calculating crowd participation. So any time where an exact number doesn't matter, but we need to get close, we use estimation. When we estimate, we deal with what are called compatible numbers. So what are they? When you hear the word compatible, you think of things that go nicely together. And that's just what compatible numbers are. It's numbers that go well with each other. In other words, numbers that we can add, subtract, multiply, and divide easily in our heads. So let's look at an example here. Suppose we wanted to add 7,957 and 5,009. With pen and paper, with a calculator, that's easy, but just in your head, it's a little more challenging. But if we don't need an exact number, we can estimate. We choose compatible numbers. So 7,957 is close to 8,000. 5,009 is close to 5,000. Now we've got two very easy numbers, 8,000 and 5,000. They share common factors. They're very simple numbers. So we have 8,000 plus 5,000 equals 13,000. Sorry, I have a little typo there. Alright, so that's what estimation is. And a couple examples of when we use it. Now we want to look at benchmarks. So what are benchmarks? Benchmarks are common numbers that serve as a reference point. So what would be some examples? Let's look at this chart here. You look at this chart, it gives you some examples of very common numbers. 25% is a quarter, or 0.25. 50% is 0.5 or half. 10%. All of these numbers are very simple to figure out. If I ask you what 10% of 900 is, you can say 90. You move the decimal place one space. All right. 10% of $10 is $1. All right. 50% of $10, $5. So figuring out the percentages of these benchmark numbers is quite simple because they're common values. It's easy to figure out or calculate a half, a quarter, 10%. So we use them when we're estimating. Suppose we want to estimate 60% of $42. Now, by using benchmarks, we can look, 60% is 10% plus 50%, both of which are relatively easy to calculate. 50% equals $21. 10% equals $4.20, which if we're estimating, we could say it's about $4. Adding them together, 60% of 42 is about $25. Now, in this example, I rounded $4.20 down to $4. But the circumstances or the specifics about the situation you're in are going to determine whether it's best to round up or round down when estimating. So that could really change. It might be that you want to round $4.20 up to $5, and then we'd have $26. So in some circumstances, you're going to want to estimate high, and in some, you're going to want to estimate low. So you need to use problem solving and logic to determine which one makes the most sense in each scenario.